Hello everybody. Today we are going to continue our chapter 6. Okay. This one is on section 6.3.3. Previously we talking about the cost function depends on at least two products, okay, x and y, and then we can find a derivative, a partial derivative with respect to x for the cost product, for the cost function, and then a partial derivative with respect to y. Okay, these are called the marginal cost. Okay, the marginal cost. And we also talking about the production function, capital P, that is depends on the labor hour and the capital that you invest. Okay, and then you can find the partial derivative with respect to L of the production function, and also the dp dk. Okay, and these two are the so-called marginal productivities. Okay, the marginal productivities, and this one they have their own interpretation as we did previously on the last clip. Okay, so today we are going to continue on the application. I mean, it's just like a direct application of the meaning, okay, of the partial derivative, okay, with respect to either the first variable or the second variable. Okay, and today we are going to talking about the so-called competitive and complementary products. Okay, so it says that sometimes two products may be related. Okay, and such that the changes in the price of one of them affect, of course, the demand of the others. Okay, if such a relationship exists between a product A and a product B, then the demand for each product is dependent on the prices of both. Okay, so it means that if your QA and the QB are the quantities demanded for A and B. Okay, so the QA is the number of unit that you want for the product A, the first product, and this one is the number of unit that the customer want for the second product. Okay, and the price A, of course, so the PA is the price of the first product and the PB is the price of the second product. Then your QA depends on both prices, okay, PA and PB, and your QB also depends on both prices, PA and PB as well. So your QA, it is a function of it is a f of PA PB, and your QB, it is another function g of PA PB. So these are a demand function for the product A and a demand function for product B. So if you finding, because you have a function, right? Okay, so let me just write down here. Your QA is a function f of PA PB, and your QB is another function of also PA and the PB as well. Okay, so what you can find is a partial derivative, right? For example, this one is a partial derivative with respect to the price A. Okay, so here is a partial derivative for the price A. What does that mean? It is a rate of change of the demand, right, as your price A change. Okay, and by changing of the price A at this moment is changing in terms of increasing. Okay, so this one is the rate of change of the demand of the product A as your price, okay, as the price of the product A is going up. Okay, so what can you conclude? What can you conclude if the price A, if the product A is more expensive, are you going to buy the A? Of course not, right? So this one always, okay, always negative. How about the second term? The second partial derivative that you can find is a partial derivative with respect to the second price, the price B. Okay, so it is the partial derivative of a demand. Okay, so it's the rate of change of a demand of the first product with respect to the price of the second product. So do we know what will happen if the second product increasing. If the second product is more expensive, what will affect to the first product? Then this one we don't know. This is what we are going to determine. Okay, so on the same token, if you're talking about the demand for the second product, okay, B, and you are finding the rate of change of the demand as your price B going up. Okay, so as your product B more expensive, what will happen to the demand for this product? Of course, this one will be decreasing, right? So here it will always decreasing, always negative, right? This is what we know from the meaning of the demand, that is depending on the price, right? However, if we try to find a partial derivative of the demand for the product B with respect to the price of the first product, so we asking what happened if the first product getting more expensive, what happened to the demand of the quantity of the product B, of the second product? Then again, here we don't know. So these two is the one that you need to really determine what happened. Okay, really determine what happened. So this is what we just analyze, right? That if the price A is going up, of course the demand for the product A will be decreasing. So this one is the one that we said always negative. And at the same token, if your price B is going up, the demand for the product B will going down. Okay, and as we told you that these two we don't know. Okay, it may be positive or negative, we still don't know. So if this one happen, so what does this mean? If this situation happen, it means that if your price B is going up, okay, if the price of the second product is going up, the demand, okay, so the demand for the first product, this one is also increasing, right? So what does this mean? If the price B is going up, of course people don't buy B, right? But they buy A more. Okay, they buy A more. And okay, it has to be N. Okay, on the other hand, if the price of A is going up, people don't buy product A, right? But people buy more of product B. So what does this mean? It means that, hey, we don't use B, we can use A instead. Or hey, we don't need to use A, we can use B instead. So they are replaceable, right? They are replaceable. So they are competitive. Is it? They have the same, the same usage. Okay. So this one, for example, you can think of butter and margarine. Is it? So if the butter is more expensive, we buy a margarine instead. If a margarine is more expensive, we buy a butter instead. Okay, so they are so-called competitive product. They are competitive, all right? And of course, on the contrary, if the price of the product B is going up, the demand for the product A is going down. So this one is decreasing. So what does this mean? If the price B going up, people don't buy B, right? But then on the same time, people don't buy A as well. And okay, it has to be N. Okay, you need to check two conditions. If the price A going up, of course people don't buy a product A. How about the B? The product B, people also don't buy because the demand is decreasing. So if B is more expensive, we don't use B and we don't use A. If the A is more expensive, we don't use A and we also don't use B. So it means that if we use A, we need to use B together. If we use B, we need to use A together. So it means that these two products, they are complementary. If you want it, you need it as a pair, you need it together. For example, I mean, even though for the last few years, this example may be obsolete, but right now the people come to use it again. Okay, the camera and the film, right? So if you buy a camera, then of course you need to buy a film. Or if you have a film, you need to have a camera to use the film, right? So it means that these two, they are complementary, and now they come back for, I mean, the teenagers, they use a camera and a film, right? So let's see some example. Okay, so oh, of course, I mean, they have to be n. Okay, so if it is the other way around, for example, if your QA and the PB, it is decreasing, and this one, your QB with respect to the price of A is increasing like this. Okay, if this situation happen, or so it means that your A and your B, it is like has no relation. So it is neither competitive nor complementary. Okay, so it has no relation at all. And on the other hand, if this one is greater than and this one is less than, okay, so it means that if the inequality sign point to the different direction, then the A and the B has no relation at all. Okay, so it has to be in the same direction, either both negative or both positive. Okay. However, I mean, to me, if I want to remember, okay, if I want to remember, I'll remember only one of them. The other will be the opposite. Okay, for example, I'll remember the competitive, that both derivative with respect to a different, you see, it has to be a different different price on the product. Okay, both of them has to be positive, then it is competitive, otherwise it is complementary. Okay, however, if you understand it the way that we introduce, then you don't really need to remember. Okay, so for example, if the demand functions for the product A and the product B, it is defined by this QA and the QB. Okay, so you can simplify a little bit. Okay, this one is actually the PA raised to the power negative 1/2 and the PB raised to the power 1/3, and for this one it is 75 PA and the PB raised to the power negative 2 or 3. Okay, so you need to find, of course, I mean, they just want you to find 4 of them, the 4 marginal demand functions, and determine whether the A and the B are competitive or complementary or neither, as I told you. Okay, so it means that you need to find 4 of them. So let's see, what is the marginal demand, okay, with respect to the price A, and what is it that you expect at the end? Of course, this one must be, okay, this one is the must. Okay, is the must, it must be negative, right? So let's see whether it is a negative or not. So here your PA is a variable, so the PB is a constant, so you just write down the 50 and the PB first, and then a derivative go directly to this PA raised to the power negative 1/2. So this is negative 1/2, and then PA raised to the power negative 3/2. Okay, and then you don't really need to simplify or anything, because it is already see that this is positive, the price always positive, right? The price is positive, so the only negative is here. so it is of course negative as we expected. Okay, don't forget that we expect it to be negative. So now what else that we can find from the demand of the product A? Of course is the demand of the product A with respect to the price B, okay, with respect to the second price. So it means that now your PA and the 50, they're constant, and the derivative go directly to the PB raised to the power 1/3, which is 1/3, PB raised to the power negative 2/3. Okay, so they are all positive, right? So we know, so this one, as we told you, that we really need to determine, okay, this is not a must, okay, we need to determine as we have the problem. Okay, so next let us find the one about the second product. Okay, the marginal demand of the product B with respect to the price. So let's do this one first, because this one we know again that it must be what? Negative. Okay, it must be negative. So let's see, it is a what? 75 PA, and then a derivative go directly to this PB raised to the power negative 2/3. So this is a PB and a negative 5/3. Of course, they are all positive except this one. So it is negative as we expected. What else that we can find? So we can find the partial derivative, okay, of a demand of the second product with respect to the first price. Okay, so now the variable is the PA itself. So this one, they are all constant, and the derivative go directly to the PA raised to the power 1, which is just 1. Is it? So they are all positive, so it is positive as well. So this one, don't forget that we find both of them, and both of them are increasing. So what does this mean? If B expensive, people don't buy B, people buy A more. If A expensive, okay, if A getting expensive, people don't buy A but buy B more. So what does this mean? They are replaceable, they are competitive. Okay, A and B are competitive product. Okay, you're right. So let's see the second example. Okay, again you need to classify whether the A and the B are complementary or competitive, okay, or has no relation at all. Okay, so if they just ask you to classify, you don't really need to find some other, 4 of them, right? All 4 marginal demand. Okay, you just find directly what you need. Okay, but this one, let me just simplify a little bit first. This is a PA raised to the power -1 and the PB raised to the power -2. So of course, to determine whether they are complementary or competitive, you need to find the marginal quantity with respect to another price. For example, the quantity A with respect to the price B. Okay, so here is your A, so it is E raised to the power negative PA or PB, and then a derivative of the inside with respect to PB. Okay, so the negative PA has nothing to do, but the derivative will go directly to 1 over PB, right? 1 over PB, it is -1, and then PB raised to the power -2. Okay, so we got 2 negative multiply, so it is a positive quantity, right? On the other hand, if you look at the QB, so we write here a derivative of a quantity B with respect to the first price. Okay, the price of the first product. So here they are all constant, derivative go directly to that quantity, so it is PA, I mean negative 1 PA raised upon negative 2. So this one is negative. Okay, so one of them is positive but the other is negative. So what does this mean? Actually there has no relation at all, right? If the price B is going up, people just buy A, but if the price A is going up, people don't buy B, so we don't have, I mean, any meaning, okay, at all about this relation. So this one, A and B, they are neither complementary or competitive. Okay, so if it happened to be like this, all right, so we'll stop this direct application of the partial derivative at this moment first. Okay, this one is pretty direct. The marginal cost, the marginal productivity, and the marginal demand with respect to the price A or the price B, okay, to determine the complementary or the competitive product. We'll see you on the next clip. Bye bye.